During this video, I will be looking at the basics of how a comparator operates. I will also be going through the necessary evidence needed to complete task 1 of assignment 3. As well as using the explanations within this video, you should also refer to the lesson document I have put up on Teams. A comparator is a type of operational amplifier. It has two inputs, the non-inverting input and the inverting input. The purpose of a voltage comparator is to take two voltages, compare them against each other, and produce an output depending on whether one output is higher than the other. With a standard comparator, if the non-inverting input voltage is larger than the inverting input voltage, the comparator will output its supply voltage. The opposite is also true. If the inverting input voltage is larger than the non-inverting input voltage, then the comparator will output a low signal. Comparators are very sensitive to changes in voltage. This means that their input voltages are very sensitive, and even the slightest difference will change the output. So the output is entirely dependent upon the two inputs. Now on the screen you can see the negative input. This is referred to as the inverting input, and the positive input, this is referred to as the non-inverting input. We also have the output voltage. Now if the non-inverting input is greater than the inverting input, the output will equal the voltage of plus VSS. And if the inverting input is greater than the non-inverting input, the output will equal minus VSS. Comparators are primarily used in digital circuit applications. Therefore, plus VSS is normally set to 5 volts and minus VSS is connected to ground, 0 volts. Therefore, you can say if the voltage at the plus input is larger than the voltage at the minus input, the output will be 5 volts. Or if the voltage at the minus input is larger than the voltage at the plus input, the output will be 0 volts. For task 1, you mainly need to focus on explaining how a comparator can be used to compare two voltages as a non-inverting comparator or as an inverting comparator. There is one more application of a comparator that you need to mention in your assignment. Comparators will always output a digital signal. The output will either be high or low. However, they are capable of receiving analog inputs. Therefore, if a comparator is able to receive analog input but only outputs digital signals, it means it can be used as an analog to digital converter. Now, many sensing devices, such as those used on car headlights or to monitor battery levels in phones, are analog sensors, but nearly all microprocessors and microcontrollers are digital. Therefore, they need a device to convert those analog signals into digital ones that they understand and can process. Comparators are used in this application. Further information about non-inverting comparators and inverting comparators can be found on Teams in the Word document labelled Comparators. That document also explains in some more detail how a comparator can be used as an analog to digital converter, as well as giving examples of its applications. Make sure you read this document fully before attempting the assignment to ensure that you do not miss any important information. In your assignment, you need to not only explain how a comparator can be used, you also need to show that you know how to use it. The video on screen is currently demonstrating, using an oscilloscope, how by adjusting the voltage at the non-inverting input, you are able to control the output of the comparator. The yellow line on the oscilloscope represents the voltage of the non-inverting input, and the red line on the oscilloscope represents the inverting input. For this experiment, the inverting input stays the same, but the non-inverting input voltage is adjusted. When the non-inverting input voltage goes above the red line, the inverting input, the LED turns on. This shows that the comparator is producing a high output. When the line goes below the inverting input voltage, the LED turns off, showing the comparator is producing a low output.
And the other way again.
The next section of this video will look at how you can use online simulations to show how a comparator works. You'll also have to do specific tests on that simulated circuit to prove and show specific values. So here we have a simulation that I've made on MultiSim Live. Now it's using a standard comparator, which can be found in analog components and ideal comparator here. Now MultiSim Live automatically puts the power in for us for this IC, so we don't have to worry about that. But we can see we still have our non-inverting input here and the inverting input here, and then this is our output. Now the idea behind this simulation is to measure the voltages going into these two inputs and then witness the effect of the LED here on the right. So you guys would want to go ahead and build this circuit to start off with. All the circuit symbols can be found on the side here, and you can check out the MultiSim Live tutorial video if you have any questions. Now, like I said, we want to be measuring the inverting here and the non-inverting input. So I'm going to go up here and grab a voltage probe. And I'm going to put a voltage probe on the non-inverting input. And I'm going to get a second voltage probe and put that on the inverting input. So now if I go and run the simulation, we can see that the non-inverting voltage is 3.7 volts, which is higher than the inverting voltage at 3.4. And our LED here is on. Now we have a potentiometer here. This allows us to vary the resistance of this component, which in turn changes the voltage at the non-inverting input. If I click the percentage, I can slide this up. Okay, and we can see that our reference voltage on the inverting input is the same, it's still 3.4, but now the non-inverting voltage is lower than that, and the output has gone low. What this is proving is the fact that this input here has to be higher than this input for the comparator to produce an output. So we're just using this simulation to show proof of concept or to explain how a comparator operates. Now the reference voltage here is being fed by the 5-volt supply through this voltage divide, which is dropping down the voltage to 3.4. I'm just going to go ahead and just increase the voltage here again and turn on the LED. Okay, so if I decrease the resistance of the potentiometer, the LED will come on when the voltage goes above this voltage. Okay, just move this here. So pay close attention to these two voltages and see at which point the LED changes. Okay. And we can actually have a look at the grapher. So if I just split the screen here. Okay, so this blue line, this is our 3.4375 voltage, which is our blue voltage probe. That is our reference voltage. As I adjust the resistance of this potentiometer, it will increase and decrease the voltage being allowed to go to the non-inverting input, which is represented by this green line. If the voltage or the green line goes above the reference voltage, okay, the LED will come on. We just have a look at the LED. Okay, so the LED is on because this voltage, this signal is above our reference voltage on our comparator. Okay, and if we go back down the other way, yeah, when it's below it, it doesn't matter how much it fluctuates, the LED stays off. If it goes above it, the LED comes on. So, like I said, the purpose of this simulation is to give you practical experience working with a comparator and also giving you an example to help you explain the theory behind how a comparator works. And hopefully you found this helpful. This video is going to continue on to look at how we can use a comparator as a battery tester. Now, hopefully a lot of you would have already built this circuit on PCB Express and would have actually had the physical circuit working in the lab before we had to break up. If you haven't been able to do that, then you need to download Express PCB and produce the PCB design for the battery tester. The circuit can be found on the brief. And then you'll need to make a simulation, which you can find on my MultiSim live channel, to help you explain how that circuit would have worked if you were able to print the circuit board and populate it. Okay. Okay, so here I have a simulation of a battery tester. It's using the same comparator that we were before. However, now the inverting input is being fed by a battery. So this here represents the DC supply, the battery that we would be testing if this was the real circuit, and then the non-inverting input is now our reference voltage. So for this to work, for the LED to come on, the inverting input must be higher than the non-inverting input. This is because I'm using the output now not as a voltage supply but as a grounding source. So when the output is 0, this LED will come on. In the previous simulation, it was working the other way around, so when this was 5 volts, the voltage went through the anode of the LED, through the cathode to ground. In this circuit, the LED always has a supply into the anode, and it can only connect to the ground through this input when it's set to 0. Okay. We've also here got 2 potentiometers now. Now, both of these potentiometers are acting as a voltage divide and will allow us to change the voltage here that we're going to be comparing our battery against. And then R1 here, this is just to ensure that these 2 resistors can never be absolutely 0 and to ensure there's always a resistance along this path. If this wasn't here and these 2 potentiometers were set to 0%, it would create a short circuit because there'd be no resistance through these wires down to ground. That short would cause the battery to overheat and could also cause damage to the potentiometers. They tend to catch fire if there's 0 resistance. So R1 here, this is just a fixed resistor to ensure there's always a small amount of resistance down this path and we don't get any shorts. So let's see this circuit in operation. Again, I've put 2 voltage probes in, one on the input here and one here on the output. If I run the simulation, okay, we can see that 1.5 is lower than our reference voltage here of 1.8. Therefore, the output is high and the LED is off because there's no potential difference between this 5 volts and this 5 volts. So there's no power running through this LED. Now if I was to adjust one of these potentiometers, so our reference voltage, just this one. Okay, so our reference voltage goes below that 1.5. You can see at this point our LED turns on. The reason the LED is now turned on is because the output is now 0 volts. This output has now become ground. There's a potential difference between our 5 volt supply and this new ground, and power can travel through the LED, turning it on. If I increase the resistance, the output goes high, no potential difference, no flow of current, no power going through the LED. So this would work to allow us to test the battery. So say we had this circuit set up and we wanted to connect this battery to it. We were testing a 1.5 volt battery and we wanted to see if this battery in real life was still fit for purpose. So I'm going to actually change this to 1.4. So in the lab, what I would say is if this battery was above 1.4 volts, then the LED would ideally come on and that battery would still be good for a little while longer. So I'm going to adjust the reference voltage so I can accurately compare again to 1.5 actually. Okay. So this is my ideal voltage. I only want to keep batteries that are at or above 1.5 volts. Anything below 1.5 volts is no longer useful as a AA battery, and I'd put that to one side and dispose of it. So this circuit is supposed to be just a quick way of testing batteries in the lab. So let's see if it works. Let's run the simulation is still running. So currently the LED is off. Therefore this battery here must not be any good because I've set my threshold voltage correctly. 1.4 volts isn't a good AA battery, so it won't power a camera or an MP3 player or a circuit, so that'd be thrown away. If I was to test my next battery, and maybe the next battery is 1.55 volts, okay, oh yeah, that battery voltage is good, it's above the voltage that I want it to be at, so I'm going to keep this battery and I'd then move that battery over to the good pile. So that's what this circuit does and how it works. You just connect in and out a battery here, and if the light came on, as long as this voltage was set right, the battery would be good. Say maybe we have a different sort of battery now. Now we're going to be testing a 1 volt battery cell. Okay, so I'm going to set it to 1 volt. So if I wanted to change the sort of battery I was testing, I'd have to readjust the reference voltage. Now I can do that because I've got my potentiometers here, and I can adjust that down to 1 volt. Okay, so now I've recalibrated the circuit, same circuit, but I've recalibrated it to test a different type of battery. So now my battery has to be above 1.0268 volts for it to be considered good. Currently my battery is 1 volt, so it's not. Maybe I'll test the next battery theoretically. Maybe that's 0.8. The LED stays off. Maybe the next battery is 0.5, really dead battery, it's not good enough. The fourth battery I test might be 1.2. Okay, that voltage is above my threshold voltage. The LED comes on, that's a good battery. So you can see how the comparator can be used as a battery tester to allow us to test batteries quickly against a reference voltage. And also you can explain and talk about how this circuit allows for that reference voltage to be altered to allow you to test different voltage batteries. Or maybe you need the battery to have more charge for some applications than others, so you might use it to divide the batteries into suitable for different jobs. Now what makes this circuit versatile are these potentiometers that allow us to change this reference voltage. However, one thing that's really important to remember is we can never test a battery that has a higher voltage than our supply voltage. So if we wanted to test maybe a 9 volt battery, we would have to increase the supply voltage of our circuit to above 9 volts to allow us to set our reference voltage to above 9 volts. Okay. So that's how the battery tester circuit would work. And in your assignment you need to explain how you can use it, how this particular simulation works, and hopefully you'll have your printed circuit board designs and your physical printed circuit boards as evidence that we did in class. If you don't have the physical board as evidence, you'll just have to explain in as much detail as you can how this circuit works, and in theory how it's able to measure and test different voltage batteries. This video is supported by a Word document on Teams that you can read through with some information written in a different way, as well as some images and graphs which are very useful for helping you explain how a comparator works. On that document there are also links to other YouTube videos explaining comparators. They're well worth the watch. And remember, the purpose of your assignments is to prove your understanding and knowledge, so you must first do the research and the learning. Once you feel you understand how a comparator works, try and formulate that understanding into an assignment using the experiments and simulations you have done to support your statements and to prove to me that you fully understand how a comparator operates. You need to talk about the inverting input, the non-inverting input. You need to explain how the comparator can be used as a analog to digital converter, and please make sure you explain specifically how this circuit can be recalibrated to measure different voltage batteries by using the potentiometers. Mention the circuit's limitations, how the circuit cannot measure a battery voltage that is greater than its supply voltage, because with our reference voltage would not be able to be set correctly. I wish you luck with your assignment and task 1. There are further videos and Word documents to support you with tasks 2 and 3. I hope that you are able to work independently at home and contact me if you have any further questions. I can do video calls and voice calls through Teams, or we can just have a text chat, whatever's best to help you.